In the late 1940s, the US Navy went on a tactical aircraft buying spree. It issued development contracts for two high-performance day fighters in the form of the wild, tailless Vought F-7U Cutlass and the almost delta-winged Douglas F-4D Skyray, and two all-weather fighters, the variable geometry Grumman F-10F Jaguar and the mostly conventional but very large McDonnell F-3H Demon. Each of these aircraft was built around new and very powerful Westinghouse J-40 turbojets. With these motors and the radical geometries of the various aircraft, the Navy would truly enter the high-performance jet game. And of course, we all know what happened. Westinghouse turned out not to be able to engineer a reliable, powerful and responsive engine. The F-11F showed promise, but it didn't have an engine and it was cancelled. The F-7U was a death trap that killed many pilots and was abruptly retired from carrier decks after a handful of cruisers. The F-3H was grossly underpowered, but as a straight-line all-weather interceptor was reasonably effective, and as was the F-4D, which was ultimately powered by a J-57. Except perhaps the F-4D, none of these aircraft came close to the performance of a contemporary land-based fighter. A well-flown MiG-19 would have made very short work of any of them, unless a Demon managed to pop it in the face with a Sparrow. So, despite the presence of their replacements, the interim F-9F Cougar and FJ-4 Fury continued to fly off US carrier decks into the second half of the 1950s. This was all in the Navy's future, but fortunately for the service there were plenty of people around whose job it was to look a bit beyond the horizon. In 1953, before their second-generation aircraft had even graced a carrier deck on operations, they embarked on programs to acquire a general-purpose day fighter and an all-weather interceptor that would see the Navy through into the 1980s. These competitions resulted in the Vought F-8U Crusader and the McDonnell F-4U Phantom II. Despite having been the main supplier of carrier fighters since the late 1920s, Grumman suddenly found themselves in a future without a combat aircraft on deck. Internally, the company believed themselves to be the victim of politics in Congress and the Navy. In reality, Grumman was likely distracted by ongoing production of the SA-16 Albatross and the S-2 Tracker, and they were outcompeted by McDonnell, who were in a golden period, and Vought, who were always slightly out there and were also desperate, having produced two pups in a row in the form of the Pirate and the Cutlass. Although Grumman management were disappointed but accepted the situation, there was a lot of pride in the engineering side of the company and thus a significant amount of resolve to stay in the fighter game. Once you're out, the way back in is always tough. Analysing the problem logically, the Grumman team realised that the Navy's procurement strategy seemed rather risky. Vought had a checkered history, and although it was definitely more conventional, the Crusader incorporated numerous innovations. The more complicated Phantom was dependent on another new and untried engine, the General Electric J79. If GE didn't deliver, then the heavy Phantom could easily be another Demon. Having successfully extended the life of the Panther by bolting on a swept wing to create the conservative but effective Cougar, the Grumman team resolved to repeat the trick. They would offer the Navy a more conventional, less risky supersonic aircraft that could act as a backstop for the more exotic types. Some hidden funds left over from the Cougar program were located, and two top engineers, Joe Gavin and Larry Mead, were assigned to lead the new fighter program. The first critical decision was the motor. Most Panthers and all Cougars were powered by a license-built Rolls-Royce Tay, made by Pratt & Whitney as the J-48. And yes, I am discounting the Allison J-33 engine variants because they were neither high-performance nor truly carrier-capable. The first generation Panther had a J-42 incidentally, which was a license-produced Rolls-Royce Nene. Those engines were centrifugal types, and although their use had been expedient as the base motors were powerful and reliable, they also led to a bulky aircraft. Since all of the R&D action was in axial turbojets, Grumman needed to choose one of these around which to design the aircraft they were referring to as Model 98. The lightest and smallest available motor with the requisite dry and afterburning power output was another license-built British engine. In this case it was the Armstrong Siddeley Sapphire, made in the US by Curtiss-Wright as the J-65. This engine was slated to power the FJ3 and 4 Fury for the Navy and the F-84F Thunderstreak for the Air Force. On the surface, using the J-65 seemed like a smart move. It was cutting edge but not unproven. More foresighted individuals pointed out that Curtiss-Wright did not have a stellar reputation for engines. This was their first jet and they had yet to design, fly or build an afterburner. Building afterburners was right on the bleeding edge of materials science and mechanical engineering at the time because of the high temperatures and pressures, not to mention the burner's interaction with the airflow of the jet ahead of it. These were problems for the future, though. Installing the axial flow motor enabled the fuselage's drag to be reduced by about 25%. The fuselage was area ruled to produce a classically shapely aircraft. Apparently the Grumman team came up with area ruling independently of Whitcomb at NACA, a result of their access to rehomed German aerodynamicists. Air intakes were moved from the wing roots to the fuselage sides. Exceptionally thin 30-degree swept wings with full-length leading-edge slats and trailing-edge flaps, and a low-mounted all-flying tail completed the aerodynamic package. The thin wings meant that the main gear moved from the wings to the fuselage. Because they were thin and light, the wings were manually folded at the ends, saving weight. 3 speed brakes were mounted on the underside of the aircraft, 1 forward of the nose gear and 2 in line with the wing trailing edge. Although it looks like a dainty aircraft, the Tiger was tough. In true Grumman fashion, it was designed to be rugged and reliable. Airframes were able to withstand over 9G without bending, even if they were only specified to 7.5. New construction techniques used on more advanced aircraft like the F-100 were also applied to the new Grumman fighter. For example, the wing surfaces were milled from a single piece of aluminium rather than tacked together from smaller sheets. The Tiger was actually the first Navy aircraft acquired to a specified airframe life, which was set at 6,000 hours. Armament was 4 Mark 12 20mm cannons mounted in the intake sides and 4 pylons on which the Navy's new Sidewinder air-to-air missile could be carried. The outer pylons were rated for £1,000 each, the inner ones could carry up to 3,500. There was no search radar, but an APG-30 gun aiming radar was provided. The Tiger was a day fighter, so this was fine, and the APG-30 was proven in an excellent system. With the specification decided, a thick brochure was submitted to the Bureau of Aeronautics in the spring of 1953, and on April the 26th, the Navy ordered 3 prototypes. Grumman was nearly back in the fighter business. A total of 41 aircraft were ordered, including a photo reconnaissance derivative. Although it now had far less in common with the Cougar than it had similarities with that aircraft, at this stage the Navy referred to it as the F9F9. Problems almost immediately surfaced with the J-65. Grumman had no experience with the motor, but an early visit to Pax River Test Centre revealed 2 issues. First, the turbine was very vulnerable to foreign object damage. The Grumman team was shown an FJ3 Fury that had ingested something sufficiently small to elude later discovery, but sufficiently large to strip all 650 aluminium blades off the axle. The Navy's solution was to have all of the rotor and stator blades remade in steel, but it wasn't a promising start. Next, Corky Mayer was dispatched to fly a Republic Thunderstreak. This experience demonstrated that the J-65 vibrated at a wide range of frequencies, seemingly independent of throttle position, altitude and angle of attack. Although apparently not dangerous, it was, again, not a great sign. "They all do that, sir," is rarely an indicator of quality. But, as it happens, the core J-65 would turn out to be a rare 1950s example of a decent, if not spectacular, jet engine. As yet, though, no afterburner was fitted. The prototype Tiger, without said afterburner, was completed in record time and completed its ground tests on July 24, 1954. Various luminaries from the Navy and from DC came down to witness the first flight. It was a hazy day, and the weather got progressively worse until the first flight was called off and the VIPs returned to DC. It wasn't until July the 30th that the weather had cleared sufficiently for the first flight to take place. It went very well, and with Mayer at the controls, a second flight was also taken in which the prototype broke the sound barrier in a shallow dive. Some alterations to the speed brakes were needed to engineer out a bit of buffeting, but otherwise things were fine. So after about 2 weeks of testing in Grumman's hands, the VIPs from the Navy were invited back for a demonstration. The Tiger prototype was undoubtedly a looker, and Meyer clearly put on a good show as the provisional order for 41 aircraft was immediately increased to 388. Further testing proved that the Tiger was a nice plane to fly. It cleared Mach 1.3 in a dive without afterburner power, and it could comfortably accept 7.5 G. Unfortunately, this first aircraft was lost when the engine flamed out and couldn't be restarted. Remarkably, the pilot, Commander Tag Livingston, didn't eject but survived despite the Tiger chopping down half of the forest it landed in. The exact cause of the flameout and failure to restart were never determined despite many attempts to replicate the exact situation leading up to the crash, entropy and the life of the test pilot. One thing that did result from the crash was an upgrade to the control hydraulics. The Tiger had a deployable ram air turbine to provide power for those hydraulics and thus the controls. The pump for those was uprated as Commander Livingston had suffered frozen controls in the crucial final seconds of his approach. It was now time to try the afterburner. The right burner was supposed to increase thrust by 50% to around 11,000 pounds, and thus allow the Tiger to hit the Mach 1.2 that Grumman had contracted for with the Navy. In January 1955, Corky Meyer took the second prototype up to 35,000 feet and lit the afterburner. The experience was not the visceral kick in the tail he had been led to expect. Instead, the Tiger accelerated slowly up to Mach 1.2 before the afterburner exploded. Hot gas punched a hole through the stainless steel shield around the burner can and exited the aircraft in a sizable fireball. When Meyer got the otherwise intact Tiger back to Edwards, the engineers discovered that the heat had started to melt the aluminium fuselage fuel tank. Meyer had, once again, been millimetres from death. Curtis's inexperience in afterburner design meant that it would be many months before their team was ready to have another go. Even so, the Navy decided that the aircraft was not a Cougar derivative anymore and it deserved its own numerical code. F9 F9 thus became F-11 F1. Corky Meyer and the Grumman team took the opportunity to observe some of the other supersonic aircraft being flown at Edwards. One of these was the F-100 Super Sabre. Without repeating the saga of the F-100's yaw instability, at around the time that Wright were redeveloping the J-65 Afterburner, several F-100s crashed and several pilots, including George Welch, were killed. In order to make their new fighter even faster, North American Aviation had fitted production F-100s with as small a fin and rudder as they thought they could get away with. Grumman had done similar with the Tiger. Unfortunately, the supersonic shockwave blanked out the small tail surface of the F-100, reducing control authority and thus preventing the pilot correcting rapidly increasing yaw angles that developed through naturally occurring directional instabilities at high speeds. In Welch's case, the F-100 yawed 15 degrees and it broke up. Realizing that they would likely have the same problem, the Grumman team significantly increased the area of the tail surfaces while the J-65 Afterburner was being re-engineered. There was plenty of time for such work, as it took Curtiss Wright until April 1956 to come back with that afterburner, manufacture it, and then supply it to Grumman. Between this and the loss of the first prototype and its instruments, the program was set back by 2 years. The W-14 version of the J-65 was still down £1,000 on specification, and as a result limited the Tiger's speed to Mach 1.05 in level flight. As soon as it was demonstrated that the afterburner wasn't going to blow up all the time, carrier suitability testing began. 66 recoveries and 56 catapult launches were conducted on the nice large deck of the USS Forrestal, using the afterburner-equipped fourth prototype and the second production aircraft. As these carrier tests were being completed, Curtiss Wright began to produce and supply W-18 engines, which gave an additional £500 of force for a total of 10,500. Top speed was therefore under the Mach 1.2 speed the Navy wanted and Grumman had hoped for. Worse still, the J-65 proved to be something of a gas guzzler in Navy testing. This led to the Navy test team concluding that the Tiger had too low a mission endurance and thus too high a cycle time to be accepted for operational service. Grumman thus needed to find a way of putting more fuel into the airframe. They considered removable tanks in the curve of the area-ruled fuselage, as you can see in this picture, but the idea was ultimately rejected by the Navy as it meant acquiring a non-standard conformal tank. Grumman therefore managed to find a way to cram an additional tank into the fin and 2 into the fuselage cheeks, increasing internal fuel from 914 to 1,092 gallons, and cycle time up to 1 hour and 40 minutes. This was below the Navy's 2-hour requirement, but by now the Navy was seemingly bored of waiting for their supposedly low-risk supersonic fighter, and they accepted the J-65 and the Tiger as they were. Besides, carrying 250-gallon drops under the wing took the cycle time up to a touch over 2 hours and 10 minutes, and allowed everybody to tick the box and get operational deployment underway. For completeness, Grumman decided to area rule the tanks, and thus created a new non-standard fuel tank anyway. They were later discarded as it turned out that the new tanks had greater drag than conventional ones. The next step was armament testing. This initially focused on the internal gun system, and it led to the incident that most enthusiasts and the odd sensational YouTuber know the Tiger for. Yes, we're now at the bit where Tom Attridge shoots himself down, thus becoming the only Tiger pilot to score a kill while flying the aircraft. Early testing of the gun system demonstrated that the Tiger suffered from the same problem as many other contemporary fighters. When the relatively rapid-firing, powerful Mark 12 cannons were fired, the large volume of gun gas produced was sucked into the engine. If the afterburner was in use when this happened, then it would blow out, particularly if the Tiger was above 40,000 feet. The burner could easily be relit, but it was an irritation. Having identified this issue, the next step was to try the same test at supersonic speeds below 20,000 feet. Because the Tiger didn't have as much power as it needed, the only reliable way to sustain Mach 1 was to perform the test in a shallow dive. Attridge went up, did the first test, and shortly thereafter landed safely. While the ground crew were refueling and rearming the jet, one of the Grumman engineers pointed out some scratches on both sides of the vertical fin. Since no one could explain them, and they were superficial, no one thought much of it. When the Tiger turned around, Attridge set off again and headed out over the Atlantic. He entered a 0.9 G dive, and when the speed passed Mach 1 and the Tiger stabilised, he fired off most of his 500 rounds. Seconds later he felt a thud, as if he had run into something. The engine immediately started to run roughly, but smoothed out when he throttled back to 70%. Attridge turned back towards Calverton, just 20 miles away, and radioed the tower that he'd hit something. Entering the landing pattern, he dropped the gear at 150 knots on final approach, and then everything went wrong. As with most combat aircraft of the time, the Tiger's controls were hydraulically actuated. An artificial feel system allowed the pilot to feel what was going on with the aircraft, even though he had no mechanical connection to the surfaces. In the Tiger, this system contained a cam that altered the stick force when the flaps were down so that the aircraft didn't become skittish. As Attridge lowered the flaps on approach, the cam kicked in, causing the aircraft to bob slightly before the pilot smoothed it out. This small amount of additional G-force caused a cannon shell, which the Tiger had flown into and had been lodged in the leading edge of the intake duct, to dislodge and enter the J-65's rotor. The effect was immediate. Engine RPM plunged. Tom Attridge cut the power, and without enough speed to make the runway or altitude to eject safely, he made a straight approach into the trees about half a mile from the runway. Once again, the Tiger demonstrated its lumberjacking abilities, albeit losing its wings and tails in the process. Attridge was able to extract himself from the cockpit. He retreated to a safe distance and waited for recovery as a small fire that had been started in the crash began to expand and cook off some residual 20mm ammunition. He was recovered by helicopter shortly afterwards. Having suffered a broken back, it was 6 months before he was able to resume flying. Later testing on a similar ejector seat found that to replicate the damage it had suffered required 68 G, so in some ways it was miraculous that Attridge had survived so unscathed. Sometime later, Navy and Grumman investigators determined that the Tiger had run into 4 cannon shells. One hit the base of the bulletproof cockpit windshield. The second went into the engine and hit the first rotor stage, causing the initial rough running. The third hit the intake duct lip and temporarily lodged there. And the fourth struck the nose cone near the in-flight refueling probe. Because Tom Attridge had flown the Tiger in the desired downwards curving trajectory to maintain speed, he'd caught up with his own shells as the unpowered projectiles slowed down. Although today this might well have caused consternation and ridicule, at the time the press was told, and then gleefully reported, how this demonstrated the US Navy's ability to make a fighter faster than a speeding bullet. Simpler times. It wasn't the only time that testing of supersonic gunfiring caused an aircraft to hit itself. An Air Force F-100 did similar only months later, but was able to land safely. Instructions went around the testing community that supersonic gunfiring should only take place with positive G on the aircraft. While weapons testing was underway, a change was made to the early production of the Tiger to extend the nose and move the location of the APG-30 gun ranging radar forward to the extreme end of the nose cone. The idea was to create space in the event that the Navy wanted to fit a search radar to the aircraft at a later point. Moving the radar meant relocating the refueling probe from the center of the nose to the front upper right portion of the nose cone. A steeply raked wing root extension was added at this time as well, which looked racy but basically did nothing. The cockpits of the two aircraft also differ considerably in terms of layout, again to allow more flexibility to install a radar scope and associated controls at a later point. What the Navy was getting with the long-nosed Tiger was a 46-foot 2-inch long aircraft with a wingspan of 31.5 feet. It weighed 13,428 pounds empty, 22,160 at normal load, and 24,078 at maximum. The short-nosed aircraft is a bit different. It was 2 feet shorter at 44 feet an inch. It weighed a bit less too, at 13,300 pounds empty, 21,280 at normal takeoff, and 23,459 at maximum. The Wright J65W18 motor gave a shade under 7,500 pounds of force dry and 10,500 with Afterburner. That gave a top speed of Mach 1.1, climb rate of about 16,500 feet per minute from sea level, and a ceiling of 50,000 feet. Thrust to mass was 0.5 and wing loading somewhere around 84 pounds per square foot. Combat range was just 300 miles, but it could ferry about 1,400 with tanks. Incidentally, in his account of the program, Corky Meyer expressed a view that even with the low-powered engine, an aerodynamic change might have given more speed and got the Tiger to Mach 1.2. Lockheed's engineers had decided not to apply the area rule to the F-104, and even though powered by the same J65 as the Tiger initially, it was able to get up to Mach 1.55. But as I said, no one was desperately keen to re-engineer the delayed Tiger again, so nothing came of that idea. The Tiger was, after all, 2 years later than planned, and thus the Navy's enthusiasm for their interim supersonic fighter had rather waned. The Crusader was only a month away from entering the fleet when initial deployments of Tigers began in February 1957. Production was therefore limited to 201 aircraft. The first 39 were short-nosed, the balance long-nosed. The Photo Tiger was cancelled before any prototypes were built. Air Development Squadron VX-3 on the East Coast received the first Tigers in February 1957 and would ultimately operate 6 of them. They took them on to Franklin D. Roosevelt and then Saratoga for carrier qualifications, and then conducted various simulated missions such as mock intercepts of high-flying A-3D Sky Warriors and in-flight refueling from AD Sky Raiders. VX-3 gave up the type in January 1958, and their aircraft were reassigned to other operational squadrons. Because of the limited number of aircraft and the availability of the Crusader, Phantom and Skyhawk, the Tiger's service life was very limited. This fact leads to a lot of quite damning analysis of the type. A very brief USNI article on it simply describes it as mediocre. 5 fleet squadrons flew it operationally, and Tigers were retired from the front line by 1962. It was mainly used as a pure fighter and a point defense interceptor, although 500-pound or 750-pound bombs or rocket pods were carried as well in practice. So is mediocre a fair assessment? Well, pilots might not have thought so when they first received the type, as they were coming off older aircraft and hadn't experienced anything faster. Of the 5 squadrons that flew it, VF-24 Fighting Checkmates transitioned from the short-lived F-3H-2M Demon and its beam-riding Sparrow 1 missiles to the Tiger. The Tiger was faster than the Demon by some margin, and it probably felt much more like a fighter plane than the heavy Demon. VF-211 Hunters also moved from the Demon. VF-33, who were the Tarsiers and then the astronauts in this period, had the FJ-3 Fury before the Tiger, which also had quite short legs, was 50 miles an hour or so slower, and it wasn't supersonic. The Fury, being loosely based on the Sabre, was still a better traditional dogfighter than the Tiger though. But it was heavy, and it was also J-65 powered. It had no afterburner. The F-156 Iron Tigers were a new squadron and the Tiger was its first aircraft. They became VF-111 Sundowners on the 20th of January 1957. The F-191 Satan's Kittens also had the FJ-3 Fury before the Tiger. All of these squadrons moved on to versions of the Crusader. As well as those who took it to sea regularly, the F-21 Macbusters deployed on Ranger in November 1957 and then became the RAG for the East Coast Tiger squadrons. The West Coast RAG was VF-121 Peacemakers. The Crusader that replaced the Tiger was a larger, more powerful and more sophisticated aircraft. It was 20% larger and heavier and it packed nearly 60% more thrust. That gave it a thrust to mass of about 0.65 versus 0.5 in the Tiger, plus Mach 1.8 speed in the earlier versions. Larger wing area meant that wing loading was about 67 pounds per square foot versus 85 in the Tiger. There wasn't really much that a Tiger pilot could do in a straight-up fight with a Crusader. For completeness, the MiG-17F has the same 0.5 thrust to mass as a Tiger, but wing loading is about 48 pounds per square foot. The Tiger was faster than the firmly subsonic Fresco, but all of the issues that the Air Force's F-100 had against the MiG-17 in Vietnam would have been suffered by the slower Tiger as well. MiG-19 was even more of an overmatch given its high thrust to mass of around 0.85 and its wing loading in the low 60s. Common to US Navy aeroplanes of the era, though, visibility was exceptional in the Tiger. All of this makes it very easy to be down on the Tiger, but we have to remember that the Navy had concluded that supersonic performance was essential in a jet fighter, even if that came at the cost of some dogfight maneuverability. If level flight supersonic performance is what you want for air superiority, then the Fury, Cougar, Skyray and Demon were dangerously inadequate against Soviet day fighters. The Tiger's numbers look modest, but had it entered service in 1956, it would have looked like a sensible upgrade. The Navy was also worried that one or both of the Crusader and Phantom would prove less good than expected. It turned out that both were excellent aircraft, particularly the F-4B, so the Tiger, which was a low-risk, lower-capability hedge, looks like it was a waste of time and a failure, but in truth it was what was needed just 2 years late. Hedges generally look expensive when you don't end up needing them, but they're insurance for the main program rather than the main event itself. The Tiger was also quite cheap to operate, it had high availability rates and it was easy to maintain. Navy records suggest that the F-11F required just 4 to 6 hours of maintenance per flight hour, which was a third less than the next nearest Navy tactical aircraft. Several ease of turnaround features were included in the design, such as an integral hoist that allowed fully loaded ammunition cans to be easily loaded up in one go. Ironically, given that it had once shot itself down with a 20mm round in the intake, on the ground the intake ducts were quite far off the deck and therefore rarely ingested anything. For engine inspection and repairs, the entire tail of the aircraft could be unbolted and wheeled away on a dolly. This was a huge improvement over something like a Demon, in which the engine had to slide out of the back of the aircraft, meaning 2 parking spaces were needed for inspections. Tough and reliable, the Tiger would go on to be used in training squadrons to prepare students for supersonic aircraft. It also provided the Blue Angels with their aircraft for nearly a decade. Captain Ed Holly, who chose the Angels' new plane in 1957, said that he went for the Tiger because, to quote, flight control response was outstanding for rolls and high-G operations in the 4-plane diamond formation. Landing approach speed was just right. The strength designed into the aircraft made it possible to pull 8 to 9 Gs in vertical maneuvers. There isn't really much more to say about the Tiger. It never saw combat, but did still do some useful service while Crusader production ramped up. By my count, 104 aircraft were lost in accidents for a slightly over 50% loss rate. Although it sounds high, that's actually par for the course in the period, and given that the Tiger was used in training and used very hard in displays, it's not that surprising. F-11 F1 became simply F-11 in 1962, but by that time the type was retired from carrier decks. Grumman also constructed the Super Tiger using the J-79 engine, but that's another aircraft in the same way that the Tiger was no longer a Cougar. One for another time. I hope you've enjoyed this short tour through the Grumman Tiger. I love an interim, and the Tiger is perhaps the archetypal interim.